Hey everyone, in this video we're going to tackle loss triangles. What are loss triangles? They are in essence just showing you how your book is performing over time from a loss perspective. So it's a triangle because it's human readable. It is not very useful to machines to read this format. But what we're looking at is for, say, 2010, or let's just use 2011, and I'll circle back on why this prior is here. For 2011, 12 months out, the losses were $780,000. A year after that, they had increased and increased and increased to other numbers, which means they are developing. So what you're looking for when you're working with loss triangles is kind of the relationship from period to period so that you can project out what you think your ultimate loss will be. That's what they're used for. Again, this format is useful to look at if you're reading it, but it's not useful to look at if you're trying to do math on it, whether in Excel or on Quantemplate. And then sometimes they come in weird variations, so in this case we've just mirrored it. And this is just to show that there's a bit of complexity that can be handled by the platform. A predication here that we will have with this example is that we've already processed the 2019 year triangles. And now what we're looking for are changes. So this number should never change because it happened, it is what it is, and it will only change out in the tail as we get more information, but this should never change. So people spend a bit of time trying to understand why those numbers change, because sometimes a different book of business or different currency assumptions are factored in. So we want to make sure that this 2010 and prior period is the same for both years. Now this, I said, was processed this 2019 year. That looks like this in the data repo as this file. And this is a easier to work with format that we can then just ultimately link everything up for 2010, 12. I want to pull this in, I want to pull in the prior period, and I want to calculate the variance, whether dollar or percent, and I'll explain those in a minute. So we're going to load these in. You can ignore this one for the moment. This is not actually being used in the pipeline now because it's already been baked into history, but the 2020 is being used. We're going to detect the headers. We're going to remove anything that has fewer than 2 rows, which will in essence get rid of these kind of sometimes populated rows that have no values in them. We're going to tag where the file came from. We're going to do some work with the headers. Cool. And then we're going to create a column called split. I could do this in the header field. I don't like doing that because of my own preference, so you can change it however you'd like. This is ultimately going to be used to split each row a bunch of times. So what we'll in essence have is a copy of this row 12 times. And then what we'll look for is different intersections of where I want to be so that I can have these 3 values be in one row, and these 3 values be in another row, and then these 3 values be in another row. There's probably some applications for swing down that might actually make this easier, which probably should be revisited, but the concept will still be the same. In essence, I just want to get these things into a single row column combination. And now thinking about that, I would absolutely just switch this out for swing down because the data sizes are also quite small. So really good application for swing down. Other than that, we're going to cleanse text from the accident year. So this 2010 and prior, I said I would tell you what that means. It's basically just grouping any years prior to 2010 into a single value because either there's not enough data or it's mature enough that it's not going to change, so you're not that worried about it. And then we'll wrap it up by just pulling out the year from the file name, the year being the snapshot of when these triangles are through, which is also going to be the lowest accident year typically on your totem pole. Then we'll have a union in case we're combining multiple files. This is where the swing down would probably replace this step in this reference file, which is basically splitting the row 12 times. It will be the same thing in effect, but we don't have to worry about that for the moment. I know this logic works, so I'm going to stick with what I know. So what this affords us is here on the outputs phase, and I'm going to close these because I don't need them anymore, is something that looks like this, where I will literally duplicate this table a lot of times. I went from a couple rows to 1200 what I'm looking for are the different intersections of accident year and period. So I know if I'm looking at accident year 2010 and I care about 2010 for period 12, then I want to keep this row and I want to only keep this value. Otherwise, basically all 11 of these rows will probably be thrown in the dumpster. And then we'll do the same for 24, and then this will just keep going up. You'll see that this number eventually changes to 11, 12, 13, 14, and so on and so forth. So we're just looking for the different intersections between the reference file, which tells me the year and the period, and which one I have access to on a given row. So 2018, period 48 is the thing I ultimately want to pull back, which is going to be this value around here. And then back to the pipeline. Once I've done that, I basically will swing all of those values into their own amount column, a generic column that is not specific to any given period year. Those will be separate tags in the data, which will make it much easier to work with, which is what you're seeing here. So again, if the accident year is the one I care about and the period is the one I care about, then let's use that. If it doesn't have any value, because we've done a one-to-many join, so all of these would be non-value rows, we'll just get rid of them. Then we'll clean up the data, get rid of anything we don't need, and we're just left with our kind of cleansed triangle. Then we can bring in that file we were looking at from the data repo. I prefaced everything with prior to indicate that we're looking at the period directly before this one. I'm going to join that, which is now going to give me the ability to link up this year's 2010 accident year period 12 value with the prior one. Now I can actually do math on it. I can calculate the dollar variance and the percent variance between those two, which is great. Now I've just saved all of the effort. One more cleanup, just because it's good to have clean data. Then I can create a validation that says, I don't want any historical data. My variance should be 0. My percent variance should be less than 5%, so that will tell me the severity between the dollar amounts and whatnot. And then I'll just clean that up, put it in a nice file that I can publish or download. And then from an output standpoint, what you're left with is something like this, where we can quickly get a rundown of, okay, we're looking at the 2020 triangles, and for some reason, we have a 32% variance over the prior year for this period. That's probably somebody made a mistake. We need to go figure out why, or dollar variance. And then that gets even simpler to view when you put it in a validation, where you can just immediately see the offending rows and the amounts. So this saves a lot of trouble. And then the final question you may have is, well, how do I get this back into a triangle format? Take it to the Analyze tab, and you can. I'm just going to create a new one to show you how fun it is. Triangle. And then we will look at, actually I just have to publish this, excuse me. Just call it temp. We will point this to temp. I have to refresh. There it is. Now I can just landscape that. I can take my accident year on one side. I can take my period on another. I can do my amount. And then you'll see we're right back in our triangle format. If you have other things that are embedded here, like risk characteristics, you could in theory start filtering these down. So if I want to look at Pennsylvania's loss triangles, if that data was embedded in claims, so you can actually make triangles from raw data similar to what, and ultimately that's where these come from, is the amalgamation of all the claims for 2011. When you start pulling through different risk characteristics, you can actually very easily start making these a little bit more dynamic and drill downable. But that's the general concept, and that is my TED Talk. This is a slightly more complicated example here of a triangle where there are different components. And this is frequently how they're presented. The format varies, but the concept is true. where you're given what we looked at before. We just looked at one of these, but in the same tab, you may be given paid, which means how much you've actually paid toward those claims, then outstanding, which is how much you still expect to have left to pay on those claims, then expenses, allocated loss adjustment expense is what this stands for, which are often broken out differently. That's paying salaries, paying claim-specific things that aren't related to the loss, and then incurred, which is the sum of all of those three things. So you now take this and you expand it out to 4 triangles in the same place, and maybe the same problem in reverse where you're given multiple formats. You can apply the same logic in that initial pipeline we just went through, the simpler example, but in essence what you just need to do is you can use fill down, which wasn't available at the time, to basically tag these rows as being paid, like that, and then outstanding, and you'd have to do some type of keyword search for it, and then you would in essence just do the same process. And then when you get to the join, you would just have one extra join point, which is you would want to duplicate your paids only, your outstandings only, and so on and so forth. So same concept. And then when you're putting this data in the reporting piece of Quantemplate, you would just filter on, the I don't know, expense type might be something you call it, something like that, where you just filter on paid triangles for a given year, and then you can kind of have that reference for all of your historical claims data.